So a couple of things we want to pay attention to with boiling point elevation. Let's get to the first one. Normal boiling points occur, okay, when vapor pressure equals 1 atmosphere. Okay, so this is when, right, this is when we're going to see that boiling point. When the vapor pressure is going to be equal to 1 atmosphere, the external pressure is 1 atmosphere. Okay, so they're equal to that. They're equal to that. So that's when we see that boiling point start to occur. Okay, but boiling point elevation, though, so solute molecules decrease the number of solvent molecules at the surface. This lowers the vapor pressure, Raoult's law, right, as we just mentioned before. So if we add, right, all these solute molecules, we understand now, right, that we're lowering the vapor pressure, as we just mentioned before with this law. That's law, right? So, right, how is this going to impact the boiling point? How is this going to impact it? So, right, lower vapor pressure, we're going to have to heat the solution more to boil it. Okay, so if we have to heat the solution more, that means that we have an elevated boiling point. Okay, because the boiling point, right, we have to accommodate because we have more solute in this solution. So for example, let's say, right, we got our pure solvent, let's just say it's water, and then, right, we add a non-volatile solute. A good example is just adding salt. Okay, I don't know if you guys ever added salt to water, but say for instance, right, depending on how much salt you add to water, you're going to have to increase the heat just to get the water to boil now. Okay, and this concept is boiling point elevation, right? Because it's the same thing that's coming to play here, right? You add more solute, it's going to impact it. It's impacting it in some way. Okay, in this case, right, like I mentioned before, Raoult's law, we lower the vapor pressure. And because of this, right, we have to increase that heat in order to get it to that gas phase now. So our boiling point has been elevated. Now, colligative properties. Let's just go over this one more time, right? Because right now I'm about to talk about boiling point elevation still, but we just in case we forgot, right? Colligative properties. Colligative properties depend on the amount of substance. The amount of substance. So we don't care about the identity of the substance. We care about the amount. The amount is key here. Okay. So if we increase, right, if we see an increase in boiling point, okay, this depends on the number of dissolved particles, as I mentioned before when we add the solute, okay, not on the type of things that were dissolved. Okay, so it depends on how many we dissolved, not on the type, how many we dissolved. This is in fact a colligative property. Now, boiling point elevation, this is the equation for boiling point elevation. We'll probably do some problems later on. We're just focused on concept right now. But this is the equation. We got our delta T, so change in temperature, right? And then we got our KB, right? So this is the molar boiling point elevation constant. So this is the constant that we're going to use for the solvent. And then we got our M solute. So in this case, the M solute, this is, notice this is a small m. This is the molality. If you remember what molality is, that's basically moles over kilograms, right? So there's instances, right, like in this case, where we have to use molality instead of molarity. Now let's look at this graph here. This is focusing on boiling point and the elevation of it, right? So I'm just going to look at boiling point because the same thing is going to occur with melting point, but boiling point, we're going to see, right, the pure solvent, right, we can see, right, that the boiling point will be here. Okay, so we got our boiling point going on here, right? Once it gets to 1 atmosphere, external pressure is 1 atmosphere. This is our boiling point. So with the pure solvent, we can see that the boiling point is at a certain degree. Once again, the temperature is increasing as we go, right? So our pure solvent boiling point is at a certain degree. With the solution, say I add particles, right, the solute to the solution. Now the solution, what do we see here? This is the red, the solution. The boiling point has increased, right? And that's because of the elevated boiling point, the colligative properties. You add a lot of solute to it, right? As I mentioned before, right? It's going to impact the boiling point. And the same thing we can see with the melting point, right? Because the solution has different properties, right? From the pure solvent. The pure solvent will be melting at this. But if you add that solute, right? So notice, right? The boiling point, you got to elevate it, right? To make up for that, all that solute that we've been added. And we can see here, right? With the solution, right? With the solution, okay, the melting point has decreased.